So today we are going to be focusing on circumference and arc length. So as a lead-in, we're going to do the circumference of each circle that is in the MDI today, and we're going to do the exact and the approximate circumference. So the formula for circumference is this: circumference is equal to pi times diameter. So remember that the diameter goes all the way across the circle. So if they only give us the radius like they do here in number 1, we have to take 2 of those. So 6.3 times 2, 6.3 plus 6.3. So the diameter in this case is equal to 12.6. So to find the exact circumference, we just take pi times the diameter, so 12.6 pi. And in this case, our label would be meters. And since circumference is just the distance around the outside edge of the circle, it's one-dimensional, so we don't square it or cube it or anything. We just leave our label as meters. The approximate, remember, takes out the pi and puts in 3.14. So we take 12.6 times 3.14. So if we take 12.6 times 3.14, we get 39.56, which I'm going to round to 39.6. And again, we're just going to put meters for our label. In the second one, the diameter has already been given to us, so we don't have to do anything with this 22. We don't need to cut it in half. We don't need to multiply it by 2. This is our diameter because it goes all the way across the circle. So our exact circumference would just be 22 pi, and in this case our label would be miles. So there's our exact. And then for the approximate, again, we're just going to take out the pi and put in 3.14. So 22 times 3.14 would be 69 point, I believe it's 48. 69.1. Sorry, I lied. Miles. And so this is our approximate circumference. In the launch, we're talking about how much longer is the edge of a 12-inch diameter pizza than a 10-inch pizza. So remember, edge is what goes around the outside of the circle. So what we're talking about here is how much bigger is the circumference of a 12-inch diameter pizza than a 10-inch diameter pizza. So again, we know that circumference is equal to pi times the diameter. So they've already given us the diameter in both of these. All we have to do is just plug that in. So we're going to do the approximate this time because it'll be easier to allow us to subtract those two values. So if we take 12 times pi, so 12 times 3.14 would give us, 37.68 inches. And then if we take 10 times 3.14, that's 31.4 inches. And if we want to find how much bigger the 12 inches than the 10 inch, we subtract those two and we get 6.28 more inches in the 12 inch than the 10 inch pizza. All right, today we're going to be focusing on calculating circumference and arc length. So the big thing here, we've already calculated the circumference in the MDI and in the launch, and that is going to be a part of what we have to do in order to calculate the arc length. So arc length is just a part of the total circumference of the circle. It's just a part of the outside edge. So an arc would be just a little piece of this outside edge here. So if we were talking about arc length, we would be talking about how long the arc is. Very simple. So again, part of this we've already done before. So if we were going to try and figure out the circumference of the circle, what we're going to try and figure out with these 4 questions right here is how long is this little piece that's highlighted here, this little red strip that's highlighted. So if we want to find the exact circumference of the circle, we just need to take pi times the diameter. Well, in this case, they give us what the radius is. So in order to find the diameter, we just have to take times 2. So 2 pi is the exact value of our circumference here. Question number 2 we've done before. When we talk about what fraction of the circle is the highlighted arc, we're talking about what fraction is this of the whole circle. So remember, if the angle is 45 degrees, that means that the arc is also 45 degrees. So if you remember, we've done measure of arc AB over 360 before. So again, we've got 45 degrees over 360 degrees, and if we reduce that, we get 1/8. So this arc right here is 1/8 of this total circumference. So if that arc is 1/8 of the total circle, then its length should be 1/8 of the circumference. So if we want to find the exact length of the arc, all we have to do is we have to take these two pieces here and multiply them together. So we take the measure of the arc over 360 and we multiply it times the circumference formula. So we know that the measure of the arc AB is 1/8, and we know that pi times the diameter is 2 pi. And just like what we did yesterday, we're going to turn this into one big fraction, and we're just going to multiply these top two pieces together. So 1 times 2 pi is 2 pi, and over 8. Now, we look at the fraction. So if we ignore the pi here, and we just look at the 2 over 8, that part is going to reduce down to 1/4. So really we have pi over 4. So this length right here is pi over 4. That's the exact length of that arc. And if we want to find the approximate length, we just take pi out and we put 3.14 in its place. So if we take 3.14 and divide by 4, we get 0.785, which I'm going to round to 0.79. So this is the approximate length of this arc. So this is also 0.79. All right, so here's the formula that we're using. So I want you guys to notice the difference in this formula versus the arc, the segment area formula. When we're talking about length, we're talking about a portion of the circumference. And so that's why we have the formula for circumference right here. Okay? When we're talking about segment area or sector area, that's when we use pi r squared here. So you have to be really careful what you're talking about. Are you talking about length or are you talking about area? Are you using circumference or are you using area? So we're just going to do a few examples. So when it says to find the length of the highlighted arc, that's the part that's highlighted in bold here. It's not really highlighted, it's more bolded than anything. So we're looking for this arc right here. So again, we're going to use that formula, measure, hold on, I'm going to back up just a second. I'm going to use AL for arc length. So measure of arc AB over 360 times pi times the diameter. Okay, because we're talking about arc length, then that means that we need to use a length formula down here, and circumference is a length. So we know that if the angle in here is 165 degrees, then that means that the arc also is 165 degrees. So if we do 165 over 360, and these should both be in degrees, our diameter is not given, but we can find it just by doubling our radius. So this would be 8 pi. And if we reduce this fraction down, I know we can divide this by 15, and we can divide this by 15. So 165 divided by 15 is 11, and 360 divided by 15 is 24, I believe. And then we still have this times 8 pi on the top. So multiply your top two pieces together so we get 8 pi over 24, and then we're just, 88 pi over 24. And then 88 and 24 can both be divided by 8. So divide this by 8, divide this by 8. So if it can't come out evenly, if it doesn't come out evenly, if you get a decimal, then reduce your fraction and just leave it in fraction terms. So this would be 11 pi over 3. So that is the length of this arc that's here in blue. On number 2, remember that this guy, this is theta, and he just means measure of the arc. It really means the measure of the angle, but since it's a central angle, the angle and the arc are the same thing. Notice that they've given us the radius here, so in order to do this formula, we're going to have to change this from a radius into a diameter. So the diameter would be 16 miles. Okay, so set up our formula first. Arc length is equal to measure of arc AB over 360 times 90 degrees, times 16 pi. pi times diameter, sorry. Now we're gonna start punching stuff in. So measure of arc AB, that's your 90 degrees over 360 times diameter is 16, so 16 pi. We're gonna reduce this fraction here, 90 over 360. These are both, we can cross these off because they're both zeros, so divide both of these by 9. So 9 divided by 9 is 1, 36 divided by 9 is 4, and then we have this times 16 pi up here. So turn this into one big fraction. So 16 pi times 1 is just 16 pi. It's over 4. 16 divided by 4 is equal to 4, so we can just change this as 4 pi. So our arc length on this one would be equal to 4 pi. On the last example, we have to be really careful on this one because what they're asking for is what is the length of this bolded section? And in order to know that, we have to know the length or the measure of this arc right here, this angle right here. But they don't give us this angle, they give us this one out here. So in order to find this one, we just have to take 360 minus 240. So we know that this is 120 degrees for this one here. So again, we're just gonna set up that formula. Arc length is equal to measure of arc AB over 360 times pi times diameter. In this case, if our angle is 120, that means that our arc is also 120. So we have arc length is equal to 120 degrees over 360 degrees times. We don't have the diameter, but we can find the diameter just by doubling the radius. So this would be 22 pi. Again, these both have zeros on the end, so we can cancel the zeros out. 12 over 36, both of these are divisible by 12. So 12 divided by 12 is 1, 36 divided by 12 is 3, times 22 pi. Turn this into one big fraction, so our arc length is equal to 22 pi over 3. 22 divided by 3 doesn't come out evenly, and neither one of them can be reduced any farther, so we would just leave this one as, this would be kilometers, this one would be miles, and this one over here would be feet. So make sure that you don't forget your labels like I did. Okay, just a reminder that your assignments are going to be collected on December 20th, which is Thursday. Please make sure that these are all on your sheet and that they are in your binder in order so that when you turn them in on Thursday, it's easier for me to flip through anything that you don't already have signed off.